So today we will talk about basic embryology, and these will be my objectives for today. Basically, at first it will be the fate of Epi Blast and Hypoblast. So what do they become or contribute to Hypoblast of the bilaminar disc? And bilaminar disc happens at week 2 because easy way is bilaminar, so it's at the second week that we're talking about. What is the major functions of prechordal plate? Second objective is the relationship between migration or invagination of the epiblast cells through the primitive streak during gastrulation. So that is your migration epiblast. Migration through the primitive streak. It runs from your ass up, basically, during gastrulation, and establishing the 3 germ layers. Next, it will be the function of the nodal cord. So, nodal cord function. Then we have the movement of the neural plate into Neuro Tube. So that is your neurulation. Neural plate into Neuro Tube. Next, we will do formation of the neural crest cells and the pathways of the neural crest cells. So, neural crest pathway. Then we will do the main divisions of the mesoderm and talk about all of the individual mesoderm from medial to the lateral, or from the nodal cord, which is medial, to all the lateral components, or the structures that it forms, the muscular mesostructures. Then we will just summarize all of the endo, ecto, so we have few categories. So it is basically in endoderm, you have just embryonic endoderm. And then we have mesoderm. In mesoderm, you have the head mesoderm, paraxial mesoderm, intermediate mesoderm, lateral plate mesoderm. That is it. So you have your head, paraxial, intermediate, and then the lateral plate. You have ectoderm, and ectoderm is basically your surface ectoderm, as well as the neural tube and neural crest. Sorry guys for this raspy voice, just early morning. Gotta get this through. And then lastly, we will just talk about the 3-layered embryo in the tube within the tube plane. So tube within a tube. And what we're talking about is basically rolling up the flat embryo into this 3-layered. So, real quick, few terminology. We're talking about human development, and human development is categorized in 2 stages. The first, embryonic stage, which goes from fertilization to 8 weeks in utero. Fetal is from 11 weeks to birth, and most of the sensitivity or the defects, the teratogens, which is right here. So your teratogen is your abnormal development, like cleft lip, cleft palate, and that usually happens. It's most sensitive in 3rd and 8th week, but it causes changes in the fetal period, which makes sense. So it's sensitive in the embryonic period. So in the first stage, we have all of the anlag, so basically the pre-structure where the structure will grow, and then we have the development in the fetal stage. So that's when you develop your organs, your nervous system. A few more definitions. You have morphogenesis, which is body form, forming of the body. Analgin, which is the organ primordia. You have fertilization, which is a fusion of the egg and the sperm. And then you have some abnormal developments like cleft lip and cleft palate, important for people doing RMS. So teratogen causes tetragenesis, or the abnormality, and teratogen can be anything like alcohol, mercury, most sensitive in third and eighth period, but it causes the defects in that fetal stage. So now we will just do a quick overview, and then I will do another detailed one. So we start with fertilization that starts in day 0 in the zona pellucida, you have the structure of zona pellucida, which is like an outer shell that protects this. And then we keep moving towards the uterus, or proximal to the uterus, throughout all these stages. So fertilization usually happens at the ampulla of the uterine tube, and then we want to be moving towards the uterus, basically. So we're always going towards the uterus. Then we have first mitotic cleavage, one cell becomes 2, DNA duplicates, then we move more to the uterus, and in this stage we have something called a morula, and this term, it just defines morula as when you have 20 to 32. Oh man, this is horrible. When you have 20 to 32 blastomeres. Sorry, 12 to 32 blastomeres, which are the individual cells. So if we have 30 of these, then we have a morula. We still have the zona pellucida outside protecting. By day 3 and 4, we are entering the uterus. And once we're in the uterus, we have the embryoblast cells. So we have the embryoblast. And the embryoblast is what becomes the baby. And then so this is the baby, whereas our trophoblast gives us the placenta. So we mostly care about the embryoblast carrying on. And then we have the blastocystic cavity, because this is a blastocyst with the embryoblast and the trophoblast. And after we are ready to implant, so the implantation happens by breaking the zona pellucida. So after you get rid of the zona pellucida, so you can see broke up. So now things can basically, so you have implantation, so in other words, embryo hatches. In this stage, you still have the trophoblast. Trophoblast. And that just gives us placenta, so we'll just ignore that. Then we have Epi Blast and Hypoblast. So that was objective 1. What is the fate of Epi Blast and Hypoblast? They make the baby, basically, and this is how that happens. So this is happening now in week 2, or the bilaminar disc. And you have 2 layers. You have that epiblast up top. You have the hypoblast on the bottom. Epiblast makes you the baby. Okay. Hypoblast gives us the signal for the head-to-tail signal. So head-to-tail signal. So that it just tells us where our mouth will be and where the colloquial membrane will be. So you have the hypoblast on the bottom, but it has this thick cortical plate, and that is what we will talk about. So that was our objective, the functions of this precordial plate and what happens. So if we zoom it in, basically, into this right here, with the precordial plate and the epiblast on the top and the hypoblast on the bottom. You can see it here. So this is the baby's back. This is the head of the baby. This is the tail of the baby. So you have the amnion or the amniotic cavity up top towards the back. You have the thick hypoblast called the precordial plate. And this is where the mouth and the head portion will be. Or anytime you see the precordial plate, you know that is where the head or the mouth is. That is the significance of that thickening of precordial plate. So after that, we would just talk about the epiblast in detail. So this is the baby's back. So we're looking at from the top, and we're looking into the baby's back, and we have something here interesting happening. Is that you have the week 3, so it's a trilaminar disc. So you have 3 layers. So week 3, 3-layer, trilaminar, and it's with gastrulation. So gastrulation makes this trilaminar disc, and then so up top of this image we have the cranial portion. So the head of the baby or the mouth of the baby. If I can draw proper today, I guess we can say this is a mouth. And then on the bottom, basically, is the caudal portion or the butt. And then, if you just want to draw a little stick guy with some legs on him and some arms. So basically, this baby will have something called the primitive streak that starts here, and it will move towards the precordial plate, and then it kind of comes back together, comes back to the primitive streak. If our primitive streak is able to pass this line, cut into the primitive streak, then we will have invagination or non-invagination, just depends. So once again, we are looking at the baby's back or the amniotic cavity on this side, the head or the umbilical, the yolk sac on the other side. As you can see, so we have our epiblast that will basically either invaginate, and if it does invaginate, basically, if it leaves this primitive streak, it can either stay in this middle space called mesoderm, or it can break the hypoblast out. So if it breaks the hypoblast out, you can see here, that will give us our endoderm. So endoderm, if you kick the hypoblast out, mesoderm stays in the middle, and then epiblast makes the ectoderm, and that is no invagination. So if it stays in the same layer, it's ectoderm. If it stays in the middle, meso, and then if it pushes hypo, it is endoderm, when inside the head or the umbilical sac. So endoderm. Neural ectoderm makes your connected central nervous system components, peripheral, and the teeth. Then you have mesoderm that mostly gives you some kind of organ, and then the endoderm that pushes the hypoblast gives you the inner tubes. That's how I like to think about it. I don't know why. So your ectoderm will make the neural tube, neural crest, and surface ectoderm. Neural tube, the most inner, so think about a tube in the center, and then you have some kind of crest outside of it. So your neural tube is basically central nervous system, so your brain, eyes, spinal cord. Neural crest is your peripheral nervous system, your sensory organ, autonomic ganglion, Schwann cells, your face, bone, cartilage, odontoblast, and then your ectoderm is your epidermis, your enamel, your ameloblast. So in dentistry, what's important here is our odontoblast Here's our amelo or enamel, ameloblast, the face bones. So most of the face component comes from this from the ectoderm. The mesoderm, mostly the muscle, we will start most medial to the notochord. So you have the notochord that gives you the spinal rod. You have the paraaxial mesoderm. So paraaxial mesoderm gives you all of the arms and legs, basically paraaxial, as well as the skin and the somite, axial somite, which is your ribs and the vertebrae. Then you have intermediate in the middle, the organ of kidney and gonads, and then most lateral mesoderm is your heart or the body lining, body cavity. And then endoderm is your inner tubes or epithelial. So the respiratory epithelial and lung lining is from endoderm. GI tract epithelial is endoderm, and your glands, like thyroid gland, liver, and pancreas, are from endoderm. So endoderm mostly gives you epithelial and the tubes or the glands, whereas the mesoderm will give you organs, mostly your ribs and vertebrae, arms and legs. In ectoderm, most of the epidermis, oral components, the central and peripheral nervous system.